So today we're starting Unit 4, and we are going to talk more about linear relations. I'm just getting some graph paper up here. I am sort of adding a page to the notes, so I apologize for that. But there was one thing that I forgot to put in there that we need to talk about. Whoops, no, I want that, okay. And really what we're focusing on today is we're going to talk a lot about slope. And this unit really sort of flows from the last one that we just talked about, which was relations and functions. We ended up talking a little bit about linear relations. And we really, in our last unit, focused on context. Right? So here's a situation. How do we present that in represent that in an equation? What does rate of change mean? What do the intercepts mean in the context? All of that kind of thing. Okay? This unit is really going to focus more on abstract stuff. Okay? So a lot more around the equation of the linear function. Different formats of the equation, because we can write that equation in several ways. How do we go between the equation and a graph? Okay, so that's really what we're going to focus on a lot more in this unit. It's not going to be as context heavy. We're going to start by talking more about slope today. If you remember from the last unit, slope and rate of change are somewhat interchangeable, right? They represent the same thing. They appear in the same spot in a linear equation. The main difference, and it's really not even a difference, is that rate of change really implies that we're dealing with a context. So you must, for example, include units in the rate of change, right? Kilometers per hour. Dollars per liter, that kind of thing, okay? When we're talking strictly about slope, there's may not be or usually is not a context attached, so it's more abstract. We're looking at the slope and how it connects with the graph. So it's, you know, it represents the same thing. Slope does not need to include units. And we're sort of just going to focus more in on that in this unit. So you'll probably hear me talk way more about slope than rate of change, okay? Now, in our last unit, we saw that slope or rate of change was the change in the dependent variable over the change in the independent. So if we're using the variables x and y, then change in dependent would be delta y. Delta means for change in. And change in independent is delta x. Okay, so delta y over delta x. We could also express that as rise over run, because our rise is our vertical change, and vertical is the dependent variable, right? Our run is the horizontal change, and that's the independent variable, okay? The letter that we usually use to represent slope is the letter M. Okay, so I'm going to use that letter instead of the word slope. Okay, so what I'd like to do to start is just say, for example, what's the slope of the line passing through A, which is, let's say, the point -3, -1, and B, which is the point 1, 5. Okay, so what is the slope of the line that passes through those 2 points? Okay, well, what's one way that we could start to figure this out? Yeah. Yeah, we could plot the points, right? And then we could just look at rise over run. So let's start out by doing that. So the point A is at -3, -1, which is right here. That's point A. And the point B is at 1, 5, which is right here. And this is the point B, and this is the point -3, -1. Okay, so I'm going to connect them. And then if I'm trying to find the slope, I can just look, well, what's the rise and what's the run? So I'm going from point A to point B. I'm going up 1, 2, 3, 4, 5, 6. And I'm going right 1, 2, 3, 4. Okay, so my slope, my rise over run, is going to be 6 over 4. Okay, and then we can reduce that. Okay, we can reduce it to 3 over 2. Now let's say I didn't want to graph it though. How could I get the value 6? The value 6 represents my rise, my change in y. That is going to come from the y coordinates, because those represent my vertical. How could I get that number 6 from the numbers 5 and -1? What would I have to do to those two numbers? Yeah.
So -1 minus 5.
You could do -1 minus 5. That would actually be -6. Or you could do 5 minus -1. So there I'm looking for a difference, difference in y coordinates. And then what about the run, which was 4? How could I get that value from the coordinates, the x coordinates 1 and -3? Yeah.
1 minus
Exactly, 1 minus -3. Okay? Because change in essentially means we're looking for a difference. Difference means subtraction. Okay? So the other way that you can get this, if you don't want to graph it, is you could go for the 6 value, 5 minus -1. We're taking a difference in y values over difference in x values, 1 minus -3. Okay, now this is quite nice because we don't actually have to graph the points to be able to get the slope. And of course, with points like this, it's not terribly hard. But if you have two coordinates where perhaps the coordinate values themselves are very, very large or very small, like in the millions, right? Or perhaps it's an irrational number or a decimal. It's kind of hard to figure out rise over run looking at those points graphically. So this allows us to do that without. Now, in general, if you have 2 points, we can call the first point x1, y1. The subscript 1 means that this is the first point that we're looking at. And we can call this one x2, y2. Okay? And that means, in general, to get slope, well, we went 5 minus -1. That represents y2 minus y1. It's a difference in y values over 1 minus -3 is x2 minus x1. X1. Not x2 minus x2. There we go. Okay, this is called the slope formula. And you guys actually get formula sheets for this course. I haven't handed them out yet because this is the first unit where there's actually anything on there that's useful. But you don't have to memorize this. This is on your formula sheet. Okay? I am going to give those out on Thursday. I want to get actually sheet protectors to give you before I do that because you guys can use these on tests and stuff like that. And so I don't want you to write on them. Okay? But yeah, I'll give those to you later this week. And that formula, the slope formula, is on there. Okay? Now, just a question. What if we swap them? Do I have to make this point x1, y1 and this one x2, y2? Or could I switch those? What do you think? Yeah.
Well, the statement you have there is implying that A is -3, comma, -1, and B is 1, comma, 5. So I mean, you could interchange the variables in the statement
Mm-hmm.
that you have there, and then I guess you could do it, but you can't arbitrarily change the variables on the graph without changing the variables in the statement, because then it's not.
Well, I mean, you have to still have these 2 points, but I chose A to be the first point, and I chose B to be the second point. So my question is, could I swap that? Could I make B the first point and A the second point? Yeah. Yeah, well, let's try it. Let's suppose that the point A, which is -3, -1, is now x2, y2. And the point B, which was 1, 5, is now x1, y1. Because before I had it in the opposite order. Okay, well now the slope is y2 minus y1, so that's -1 minus 5 over x2 minus x1, -3 minus 1. Okay, well this makes -6 over -4. What does that reduce to? Yep. Which one's it going to, is it -3/2 or +3/2? Yeah. Positive, yeah, because we've got 2 negative signs. So this is still 3/2. Yeah, so it really doesn't matter. It's arbitrary which point you choose to be x1, y1 and x2, y2. Okay? All right. Questions with that? We're going to be using this formula a lot today, because what we're going to be looking at is we're going to be looking at different types of lines. So we're going to be looking at horizontal lines, vertical lines, and then for the most part, parallel and perpendicular lines. And what we really need to consider when we're looking at these types of lines is what's the property of their slope, or what's the properties of their slopes. Okay? If we look at a horizontal line, what is the slope of any horizontal line? What's the slope of any vertical line? Right? And then if we're looking at parallel or perpendicular lines, we have to have at least 2 lines. So what do their slopes have to do with one another? Okay? That's kind of going to be our focus for today. All right. So first, let's look at a horizontal line. So I'm just going to draw one for example. For example, let's say this is at 3. And there's my horizontal line. Okay, so this point over here, y-intercept, the x-coordinate 0, so this is the point 0, 3. And then I could choose any other point on that line. What's the y-coordinate of any point on this line? Yeah, 3, because I'm at a height of 3. Vertically, I'm at 3. X could be anything. So let's say here's 5, and I look at the point 5, 3, for example. Okay. Now, if I try and find the slope of between these 2 points, okay, I can either use rise over run, or I could use the slope formula. Let's maybe use the slope formula here. So if I make this guy x1, y1, and this one x2, y2, my y2 minus y1 is 3 minus 3. And my x2 minus x1 is 5 minus 0. Okay, so the slope becomes 3 minus 3 is 0 over 5 minus 0 is 5. Okay. What's the value of 0 over 5? Yeah, 0. Yeah. So horizontal lines always have a slope of 0. Because if you think about it, if you're horizontal, your rise is nothing. You're not going up at all. You're just moving along. Your run can be anything, but your rise is always 0. 0 divided by anything is just 0. Okay? So horizontal lines always have slopes of 0. Okay. Now the equation of this line We've already said x can be anything. The important thing is that y has to have the coordinate 3, because we're always at a height of 3. If you're always at a height of 3, you are always horizontal. So the equation here is we don't care about the x coordinate, we just care about the y coordinate. Y has to equal 3. So the equation of a horizontal line actually doesn't bring x into the picture at all. Okay? And in general, the equation of a horizontal line is that y equals some number, and that number is whatever the height of the line is, right? So if it was down here like at -1, it would be y equals -1. If it was way up here at 10, it would be y equals 10. Okay, so the equation is always of the form y equals a number. Slope is 0. The equation is that y equals some number, and that number is whatever height the line is at. Okay? Vertical lines. Well, if we draw a vertical line, let's say I have over here, -4. There's my vertical line. Okay, and this point here, that's the x-intercept. Well, the x value is -4, the y value is 0. So this could be the point -4, 0, or it is the point -4, 0. Maybe I can pick another point on this line, maybe up here. That is, maybe let's say that's 6. This would be the point -4, 6. Okay, so if I try to find the slope here, maybe this time I can use rise over run, because what I really want you guys to see is that those are interchangeable, right? And you can use either one. Well, going from this point to this point, what is my rise? 6. What's my run? How much have I moved horizontally? 0. Yeah. Okay, well, tell me about that. What can we say about 6 divided by 0? Yeah, it's not possible. Yeah, anything divided by 0 is an undefined value. So vertical lines have undefined slopes. Okay. By the way, does anyone know why a number divided by 0 is undefined? No? Yes? Anyone? Yeah?
We were taught this last year, but my mind is just
Okay. So you're taught it. So there's 3 explanations that I typically use, and it really depends on the age group of the people that I'm working with, right? So when I'm talking to my own children who are 6 and 8, I'll say, well, if you have 6 cookies and you want to divvy them up amongst 0 people, how do you do that? Where do the cookies go? You can't. They have to go somewhere, but they've got to go to 0 people. You can't do that. Doesn't make sense, okay? When I talk to junior high students, I talk about the fact that multiplication and division are opposite processes. So let's say you take any multiplication statement, 2 times 4 equals 8, okay? This group of numbers, there's actually 3 other statements that we can make that are true using multiplication and division. We can also say 4 times 2 equals 8. Those are the 2 multiplication statements. The 2 division statements would be 8 divided by 4 equals 2, or 8 divided by 2 equals 4. Okay? So suppose you could have a number, let's say you take, I don't know, 5 divided by 0, and you get some number. We don't know what it is, but let's say some number exists where this is true. Okay? Well, then what you must also have is that that number times 0 has to give you 5. Okay? That would be the analogous multiplication statement. Well, this is impossible because anything times 0 is 0. So on the left side, we have 0. On the right side, we have 5. Those two numbers are not equal to one another. Okay, so that's typically the explanation that I talk about when I'm looking at junior high, that sort of age, or even maybe a little younger. Once we get into high school, we can actually start talking about graphically what happens when you divide by 0. Okay, so if you take the function, and you guys may not fully understand this at this point, but that's okay. This is more like grade 11 material. Y equals 1 over x. So y equals 1 divided by some number. Well, if x is 2, then the y value would be 1/2. So that's pretty simple. If, though, you want x to be 0, and you look at what happens at the graph, as you come towards 0 on the right, these values shoot up towards infinity. Because if you take 1 and divide it by a very, very small number, something close to 0, 1 divided by a very, very small number is a very, very large number, right? So 1 divided by 1/10 is 10. 1 divided by 100th is 100. 1 divided by 1,000th is 1,000. The closer to 0 you get, the higher these numbers get. They shoot up towards infinity, okay? Conversely, if you approach 0 on this side, from the negative side, well, now all of those numbers that we just talked about are going to have negative values. So coming from the left, this shoots towards negative infinity. Okay? That means you can't divide by 0 because as you approach from either side of 0, from the right and the left, you get this divergence. Okay, so this is more almost leading into calculus. You will look at this a little bit either in 20-1 or 30-2 when you look at rational expressions and things like that, rational functions. Okay, but that's a couple explanations as to why we can't divide by 0. Where did my page go? There we go. Okay. But yeah, important thing to remember about vertical lines is that they have undefined slopes because the run, which is in the denominator, is 0. Okay? What do you think the equation of this line would be? For the horizontal line, the equation was y equals 3. Yeah. Yes. The equation is now x equals a number. In this case, -4. Because, again, it doesn't matter where you are vertically, you just have to horizontally be at 4. -4, not 4, okay? So in general, the equation is just x equals some number. That represents a vertical line. These guys are not functions, okay? Because firstly, it doesn't pass the vertical line test, and also the input is always -4, and you get infinite different outputs. Okay, so that's another reason why these aren't functions. Okay, parallel lines. So when we're talking about parallel lines, we have to have at least 2 lines or more. What can you tell me about parallel lines? What's one thing that we know about them? Yeah. They never intersect. Correct. They never meet. So like in Calgary, streets are parallel to one another, avenues are parallel to one another. Okay? If someone says, I want to meet you at the corner of 7th Street and 10th Street, they probably don't want to see you. Okay? Yeah, so parallel lines do not intersect. Okay? Now, if we look at lines that are parallel, What do you think that means about their slopes? Rise over run. Yeah, Anna. They are equal to one another, exactly. Parallel lines have equal slopes. Okay, so the symbol that we use to show that two lines are parallel is we put like an arrow on each one. Or if sometimes you might use two arrows on each one, something like that. And also the symbol that we use for parallel lines looks quite similar. Looks like this. Parallel lines have equal slopes. Okay. Perpendicular lines. Well, if two lines are perpendicular to one another, what can we say about those lines? Yeah.
They need to intersect.
They do intersect. Yeah, they have to intersect a specific way though. Yeah.
At a right angle.
At a right angle. Yeah, they intersect at a right or 90-degree angle. Okay. Okay, so their slopes are not going to be the same, but they are related to one another. And the proof for this is a little bit complex. So what I want to do is just show you a couple of examples. Whoops, let me just do this actually on my laptop. It'll be easier. And then we can try and make a generalization. Okay, so the first two that I'm going to look at are sort of the diagonal lines, this guy and this guy. So if I look at these two lines, there's one. I don't know why, but the axis is a little bit off here. There's the other. Okay, this first line, if you look at the slope, let's say I go from the origin to this point, the point 2, 2. I'm going up 2, right 2. So my slope is 2 over 2, which is, yep, 1. Yes. Okay. If I look at this slope, okay, and let's say this is the point -2, 2. Well, to get from the origin to this point, I'm going up to left 2. So what would the slope of that line be? Yeah, -1. It's 2 over -2, which is -1. Okay, all right, so this is one thing that we can notice. Right? If you think about perpendicular lines, they have to sort of slant in opposite directions, right? So what does that mean about the value of their slope? If one of them slants up towards the right and one of them slants down towards the right, they're going to have opposite signs. Okay, so that's one thing we need to know. Okay, hopefully we're still in business there. Okay. Now we may also think here that they have the same magnitude. That could be a theory, but we have to check that a little bit more. So I am going to give you one more example. Okay. And now let's look at another line. So this time I'm going to take a line with a slope of 2. Right? So it has a slope of 2 because to get from this point to this point, I'm going up to right 2. And then to get from this point to this, or sorry, up to right 1. My bad. And then again, I go up to right 1, up to right 1. You can kind of think of these as a staircase. Okay, Now, if I drew in a slope of -2, which would go this way, it would kind of be a reflection in the y-axis, would those two lines be perpendicular to one another? No, right? This one would kind of be angled like this if it had a slope of -2. So those are not perpendicular. That's not a 90-degree angle, okay? So that's not going to work. If we actually draw a perpendicular line, then it has to be more like this. That is a perpendicular line. Okay, so yeah, it is going to slant down towards the right as we go from left to right, but it's not a reflection like that one was in the y-axis. Okay, if we take a look at this slope, here to get from the origin to this point, we're going down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Okay, so you're almost taking this little staircase and turning it sideways. Okay, this guy has a slope of up to right 1, so that's 2 over 1. That's our rise over run. This guy has a slope of down 1, right 2. Well, down 1 means that my rise has to be -1 over 2. Okay, so the two slopes, if they are perpendicular, are negatives of one another. What else can we say about them? One, like the magnitudes, this one was 2 over 1, this one was 1 over 2. Yeah. You forget the word, but can you describe it? Yeah, they are, and do you remember what that is? Reciprocals, yes. So slopes of perpendicular lines are called negative reciprocals of one another. Reciprocal means we switch the numerator and denominator, and really what we're switching here actually is the rise and the run, right? Here we go up 2, right 1, up 2, right 1. So the up motion is 2 units, the side to side is 1 unit, and here the up or down motion is again 1 unit and right 2 units. They also have to have opposite signs, okay? So they are negative reciprocals of one another. And that's true of these two numbers here as well, 1 and -1, because these both have denominators of 1, right? So if you flip them, you still get 1 over 1. Okay, so perpendicular lines, and this is the symbol that we use for perpendicular. It's like an upside down T with a little perpendicular symbol in it, have slopes that are negative reciprocals. Of one another. Okay, so what does that mean? They have to have different signs, and the numerator and the denominator must be flipped. Yeah?
So if we're looking at like the second example first,
Yeah.
is it still called a negative reciprocal even though the slope is negative to begin with, but define this one? We just change the magnitude.
Yeah, so like if you started with this line, the -1 over 2, the negative reciprocal of that is -1 over 2. So you just stick a negative sign in front of it. But if you stick a negative sign in front of a negative value, the two negatives make a positive. So you will always, no matter which one you start with, they will always have opposite signs. Yeah. One thing that I want to mention about parallel and perpendicular lines is that it's really tempting to say, yes, these are parallel because they look parallel. Or yes, these are perpendicular because they look perpendicular. But we cannot rely on our eyesight to prove that two lines are parallel or perpendicular. The reason for that is that our eyes are not good enough to tell the difference between 90 degrees and 90.01 degrees. Okay, so the 90 degree would be perpendicular. 90.01 is not perpendicular, but it's so close to perpendicular that we can't discern the difference, okay? What does that mean? It means that we have to justify by looking at slopes that two lines are either parallel or perpendicular, okay? What you can do using your eyesight is rule something out. Because if something is very obviously not parallel or not perpendicular, we can say, oh yeah, definitely not. But if it is, it may just look like it is, okay? So that's one thing that I wanted to mention. All right, let's look at an example. Oh, I think I added a couple pages. There we go. Okay, so line GH passes through G, -4, 2, and H, 2, -1. Line JK passes through these 2 points, J and K. I'm not going to read them out. And line MN passes through these 2 points, -4, 5, 5, 1. Okay, so the first thing that we are asked to do is sketch the lines, and then we need to say if they're parallel or not, and we have to justify that. Okay, so let's just start by sketching. So G is -4, 2, so that point is right here. And H is 2, -1, which is right here. Okay, so there's line GH. And by the way, actually, I should write these beyond those 2 points as well. Because, and I know this is being like super picky, but I actually haven't drawn a line here. I've drawn a line segment. Does anyone know what the difference is? Yeah.
A line segment is a connection between two variables.
Yeah, kind of.
Line goes on forever.
Yeah, a line is infinite. A line segment, a part of a line, is finite. So technically, the way I've drawn it, it's just a line segment. If I want to show that it's a line, I need to show that it actually goes on forever in both directions. Okay, do you know what it's called if it only goes on forever in one direction? Probably, if you've seen this before, it was a really, really long time ago. It's called a ray. Yeah, yeah, okay. You won't have to deal with that kind of thing in this course, I don't think. Okay, all right, so JK goes to the points J, -1, 7, so here's -1, 7, and K is at 7, 3, 7, 3. JK. There we go. And I'll just extend those a little bit because this is also a line. Okay, and then finally MN passes through -4, 5. There's M. And N is at 5, 1. Okay, so there is MN. Okay, so just visually, is it possible that these are parallel? Yeah. They look like any two of them or all three of them could be parallel to one another. Okay, so we can't use vision or eyesight to rule anything out here. Okay, now, how do we show that two lines are parallel? Well, we have to actually take a close look at their slopes. So what we're going to do next is use that slope formula to calculate all three slopes. Okay, so one thing that I find helpful to do when I'm using the slope formula, because actually even I often plug things in the wrong spot, is above each point, just choose one to be x1, y1, and the other one to be x2, y2. And then you can see, just write those labels above, and then you can see exactly what the values are. So if this guy is x1, y1, and this one is x2, y2, then when I'm plugging in, I can say, okay, y2 is -1, y1 is 2. And it just sort of provides some clarity there. Okay? All right, so we're going to find three different slopes here. What I'm going to do is I'm going to use the letters connecting the line in the subscript to differentiate one from another. Okay? So the slope of GH would be -1 minus 2 over 2 minus -4. Watch out for the double negative. We're subtracting a negative there. Okay, and that becomes negative 3 over 6. And then a really handy thing to do, particularly when you are comparing several slopes, is to make sure they're reduced. So we can reduce this to negative 1 over 2. Okay? All right, so JK, again, I'm going to do this. X1, Y1, X2, Y2. And then my slope is y2 minus y1, 3 minus 7, over x2 minus x1, 7 minus negative 1. And that becomes 3 minus 7 is negative 4. And 7 minus negative 1 is 8. Okay, and that also reduces to negative 1/2. So we found two lines that are parallel to one another because they have equal slopes. Okay, let's look at the third one. So MN, I'm just going to switch it up this time, and I'm going to make the first point x2, y2, and the second one x1, y1. Because as we saw at the beginning, it really doesn't matter. So this time I'm going y2 minus y1, 5 minus 1, over x2 minus x1, negative 4 minus 5. And that becomes 5 minus 1 is 4, over negative 4 minus 5 is negative 9. Okay, so what can we say about this line? Yeah. Correct. It's not parallel to the other two. Okay? So GH is parallel to JK. This statement basically says that these two lines are parallel to one another. MN is not. Okay? All right, slopes of perpendicular lines. These are negative reciprocals. We already spoke about this. The word oblique is in here. That means slanted. But actually, this would sort of be true for perpendicular and vertical, or not perpendicular, vertical and horizontal lines as well, right? If you have one of them as 0 over 1, and the other one is negative 1 over 0, you still have a slope of 0 and a slope of undefined, right? Okay, so these slopes are negative reciprocals of one another. Okay, so just so that we can practice what to look for, suppose one line has a slope of 3/4. What would the slope of the perpendicular line be? If one of them is 3/4, what would the other slope be so that the two lines are perpendicular? Yeah. Almost, not quite. It's not 4 over 3. Negative 4 over 3, yes. So they have to have opposite signs and reciprocals. So this guy would be negative 4 over 3. What about if one slope was negative 1/2? What would the slope of the perpendicular line be? Yeah. 2 over 1, yeah. Or you could just write it as 2. Okay, and what if one line has a slope of 6? Yes. There you go, negative 1 over 6, right? Because 6 as a fraction is 6 over 1. So this guy would be negative 1 over 6. Okay. The other thing that I want to mention, just about, just a reminder around negative fractions, because a lot of slopes appear as negative fractions, is that remember that these three values are equal to one another. I'm going to use the example of negative 4 over 3. Negative 4 over 3 equals 4 over negative 3, which equals negative 4 over 3. Okay, so just keep that in mind. They all have the same value. Now, Another thing that I'm just going to quickly mention, because this came up in my last class, and it was a good point, is that when we talked about rate of change in that context, we often wrote that value as a decimal, right? So if the rate of change is 1.5, that could represent $1.50 per can of pop. So we would write that as a decimal, right? When we're dealing with stuff that's more abstract, more often you will see that value written as like 3/2 instead of 1.5. The reason for that is that having it written as a reduced fraction allows us to very easily go from the equation to the graph, because that 3/2 means from point to point we have a rise of 3 and a run of 2. And in decimal form, it's not as easy to see that, okay? So if you wrote this as 0.5 instead of 3/4, it's not that it's wrong, but it's just a little bit more challenging to graph because it's not as easy to see the rise and the run in decimal form, okay? I personally, when I'm thinking about rise and run, if I have something that's negative 4/3, I'll pop the negative sign either into the numerator or denominator, because if it's written this first way, negative 4/3, that means I'm going down 4, right 3. If it's written this way, I'm going up 4, left 3. So it really just gives me directions, okay? All right. Let's take a look at these two. So line PQ passes through P -7, 2 and Q -2, 10. Line RS passes through -3, -4, and 5, 1. Okay, so the first thing we are asked to do is to answer this question: are these two lines parallel, perpendicular, or neither? And we need to justify that. And then we're going to sketch to verify. Yep.
This is unrelated, but how long do you think this unit is going to take?
How long will this unit take? I have to look at the calendar, but it's somewhere around 2 weeks-ish. We'll be done in about 2 weeks. Yeah.
What percentage of your grade?
What percent? I can't remember. About the same as all the other ones. They're all somewhere between like 12 and 15%, something like that. This is an important unit though, right? And so just like I told you guys with factoring, that's one thing, one skill that I look at when I'm making recommendations around moving into 20-1 or 20-2. This is the other unit that I look at, okay? Because you have to have strong algebra skills in this unit when we look at the 3 different forms of a linear equation, and you have to have good graphing skills and things like that. And those are skills that are very heavy in 20-1. Okay, we still use them in the -2 stream, of course, as well, but not as much. Okay, let's go back to this though. Are they parallel, perpendicular, or neither? So we can always tell from the slopes. So we are going to calculate the slopes of these two lines. Okay, so the slope of PQ is, if this is x1, y1, x2, y2. Thank you. Okay. Y2 minus y1 is 10 minus 2. X2 minus x1 is -2 minus -7. Okay, so that becomes 10 minus 2 is 8. -2 minus -7 is -2 plus 7, which is 5. Okay, and then if we look at the slope of this line, the slope of RS, I'm going to switch this again. X2, Y2, X1, Y1. And when I switch, there's no, I don't have a grand scheme there except to expose you guys to lots of different ways of doing things and to show you that they are all the same. Okay. Okay, so here, y2 minus y1 is -4 minus 1. And x2 minus x1 is -3 minus 5. So this becomes -4 minus 1 is -5, Negative 3 minus 5 is negative 8. Okay, can I simplify that? I can't simplify the numerical part. What about the signs? Yeah.
If you flip the fraction, it changes the signs.
If I flip the fraction, changes, not quite. What's a negative divided by a negative though? Yeah, it's a positive. Yeah. So if you can do that, if you have a negative divided by a negative, simplify that and make it positive, because what we're really trying to do here is a comparison, right? And if it's written this way as opposed to that way, we may think that these actually have opposite signs when in fact they don't. They both have positive values. Okay, so what can we say about these? Are they parallel? No, if they're parallel, their slopes have to be equal. Are they perpendicular? They're not. No, why not? Yeah. Right, yeah. They're reciprocals, but they're not negative reciprocals. They must be negative reciprocals, okay? And if we sketch this, we'll see that this is verified. So the point P is at negative 7, 2, and Q is at negative 2, 10. So that's this guy. And then our S is at negative 3, negative 4. And S is at 5, 1. Here's the other one. Okay, so we can see if these continue, they're going to meet down here somewhere in the third quadrant. And it's not going to be at a perpendicular angle. Okay? All right, so I'm going to get you guys to try this one. Then we'll do a couple more examples, and then we'll be done for today. All right, so here's another type of example. Here, in this example, what we're going to do is start with one line and try and figure out what the coordinates would be of another line so that the two lines are perpendicular to one another. Okay, so determine the slope of a line that is perpendicular to the line through E, 2, 3, and F, 4, negative 1. So we want to know what's the slope of the perpendicular line first. Okay, well, how would we figure that out? How would we figure out the slope of the line perpendicular to EF? Yeah. Yeah, use the slope formula to figure out what exactly. Yes.
The negative reciprocal of that?
Well, first we have to find what's that.
Yeah, we have to find out, like, what y2 minus y1.
What do we want the slope of? Yes.
EF.
Yeah, we want the slope of EF. Once we figure out the slope of EF, we just take its negative reciprocal. That's our slope of the perpendicular line. Okay, so that's what we're going to do first. Here's EF. I'm just going to, I keep trying to switch the thickness, but it doesn't work, so I don't know why I keep doing that. I'm going to call this x1, y1, x2, y2. Okay, one thing I noticed when I was walking around is that several of you are not taking time to write this thing down, and then you are making sign errors. And unfortunately, in this unit, we are looking at specifics. So, like, there's not a lot of, you're not going to get like 3/4 of the question right if you make that kind of sign error. That's exactly what we're looking for. Can you slow down and like write things down, take the time that you need to make sure you don't make those types of careless errors, right? This kind of thing, this kind of strategy can help. Okay, the other thing that you might want to do is actually write the formula out before you start plugging things in. Right, so it's very mechanical. You don't actually start calculating anything until these numbers are in there. So what is y2? It's negative 1. Minus, what is y1? It's 3. And then x2 is negative 4. Minus x1 is 2. Okay, now you can start calculating. So this becomes negative 4 over negative 6. Okay, and then we can reduce that to 2/3, and actually the negatives both cancel. So negative divided by negative is positive. Okay, so this is the slope of EF. What is the slope of the perpendicular line going to be? Yeah. Slope of the perpendicular line is, we have to do two things. Take the reciprocal of that, which is 3/2, and switch the sign. This one's positive, so the other one has to be negative. Okay? Okay, so that's the first part of the question. That's A. Question B. Determine the coordinates of G so that the line EG is perpendicular to the line EF. So now we actually want to know, okay, if these two lines are perpendicular, one of them's EG and one of them's EF, what could G be? What could the coordinates of G be? Okay, now in this, for this part, I would recommend drawing EF first because we really want to see visually, if we're looking for coordinates, it's helpful to be able to look at a graph. So let's put EF down first. E is at 2, 3. And F is at -4, -1. So here's EF. Okay, and what we want to know is what's G so that these two lines, so that EG and EF are perpendicular. Well, given that we're looking at EG, what's the point that's going to be on both lines? Yeah, E. Point E has to be on both lines. So this is going to be where they intersect. We know that that point is also on the perpendicular line because we're told EG, those two points connect. We want to know what could G be? Well, if we know one point on the line and we know the slope, we can use the slope, think rise over run, to get other points on the line. Okay? So if I think of this as -3/2 or as 3/2, okay? If I think of the slope with the negative sign in the numerator, this means from any point in the line, I can find the next one by going down 3, right 2. Down 3, right 2. Or if I think about it this way, I can find any point on the line by going up 3, left 2. Up 3, left 2. Yeah?
I was just wondering, is Bree still out?
Yeah. Okay, so starting at this point, oh shoot, I don't want to do that. I'm going to use my slope to give me directions to find other points on the line. So if I use the first version, that means I go down 3 first, then right 2. Down 3, right 2. Here's another point. Down 3, right 2. Here's another point. Down 3, right 2. Here's another point. Okay, if I use this version, 3/2, that means I go up first, but then left. So I'm going to go up 3, left 2. Up 3, left 2. Okay, this makes the line. Now, what could G be? G could be any of these points. So there are infinite answers for what G could be. It's just any of the other points on that line, right? So G could be this point over here is -2, 9. It could also be this point, which is 0, 6. Can't be E, because if E and G overlap, we actually don't have a line. right? We just have a point. So that's the only one it can't be, is that intersection point. But it could be this one. This is 4, 0. It could be this one, which is 6, -3, etc. Whoops. Okay, so there are multiple answers for what G could be, but essentially what you want to do is use the slope, the rise over run, to find other points on the line. And then you just name any one of those points. Okay? All right, so I'm going to get you guys to try this one, and then we have one more question to do, and then we'll be done. All right, last question. ABCD is a parallelogram. Is it a rectangle? And justify your answer. Okay, so we have this shape. It's on a coordinate plane, and we're told that it's a parallelogram. Okay, what a parallelogram means is it's a quadrilateral. It's got 4 sides, and opposite sides are parallel. Okay, so something like this is a parallelogram where I've got 2 sets of parallel sides. Okay? We want to know, is it also a rectangle? So if this is a rectangle, the qualities of a rectangle or properties of a rectangle is that it has to have 4 right angles. Okay? So if we were just asked if this shape was a rectangle, we'd actually have to calculate the slopes of all 4 line segments. But given that it's a parallelogram, we actually can reduce some of the work that we have to do. Because, and this might be going back a little bit, but if you remember some properties of parallel lines, if you have a set of parallel lines and then a line that intersects them, that's called a transversal. Basically 8 angles are created by that intersection. And the angles have relationships with one another, okay? So this angle up here and this angle over here are equivalent. They're called alternate interior angles. This angle here and this angle here are also equivalent. They're called corresponding angles, okay? This angle and this angle, well, those are not equivalent. One of them is acute, one of them is obtuse. However, they do, since these are equal, add up to 180. They are supplementary. Supplementary meaning they add to 180. And we can see, you know, these 2 over here are supplementary. And because this one's equal to this one, they must also equal 180 degrees. That's really useful because if we can show that one of the angles in this quadrilateral is a 90-degree angle, all of the other ones are going to fall into place. Because if, you know, if this one, let's say, is 90, well, this one and this one have to add to 180. So that means the other one's 90 as well. And then this one and this one have to add to 180. And then this one and this one have to add to 180. So it's almost like a domino effect. But the nice thing is that we only actually have to find the slopes of 2 of the line segments and show that they're perpendicular. And then we can prove that this is, in fact, a rectangle. If we did not know that it was a parallelogram, then we'd actually have to find the slopes of all 4. Okay, and show that they're all perpendicular to one another. Okay, so let's just pick 2 of them. And we can maybe use rise over run here because we have a graph. So if we're looking at the slope between A and B, well, to get from A to B, I'm going down 4 and right 1. So my rise over run is -4 over 1. Down 4, right 1. And then if I'm looking at the slope from C to B, from this point to this point, well, here to get from B to C, I have to go up. And I'm going up 2, and then right, and I'm going right 2, 4, 6, 8. So my slope here is up 2, right 8. Rise over run is 2 over 8. And this, of course, reduces to 1/4. Okay? Now, when I compare these guys, these are negative reciprocals. So we can say that AB is perpendicular to BC. And because this angle is perpendicular as we said a couple minutes ago, well, because these are parallel, these angles have to add to 180. If one of them is 90, the other one has to be 90 as well. And then these angles have to add to 180. And this last pair also has to add to 180. So this is, in fact, a rectangle. Okay, and we're going to leave it there. We will continue looking at linear relations and slope on Thursday.